All right, Algebra 1A folks, this should be the last video on this quiz on multi-step equations. We're going to finish up here the last four problems. Two of them are story problems, number 7 and 8, and then 9 and 10 are checking. And we're going to skip the challenge question. We're going to leave that for you to see if you can figure that out on your own, folks. But here we go with the story problems. Number 7, we're supposed to answer the question, show work, or give an explanation. And number 7, we have here 2/3 of a pizza costs $15. What would a whole pizza cost? So of course, if you wanted to, 2/3 maybe not that bad of a fraction. If you wanted to try to draw yourself a picture and say, let's pretend there's our pizza and we cut it into pieces, and 2/3 costs $15. I'm gonna take a different approach here because I want us to have a general approach that we could do anything for. So cost of a pizza, I'm gonna call that P. I'm gonna use the variable P to represent the cost of a whole pizza, and then 2/3 of a pizza, that would be multiplication. That'd be two thirds, excuse me, times a whole pizza, and the cost, that would be your equal sign here. That's gonna equal $15. So if you can make sense of that, writing down that equation, whatever variable you want to use for the cost of the whole pizza, maybe use X, whatever. But if you can get that equation, that idea that, hey, well, now we just moved the water from the table to the desk. Now we have to boil the water. But this looks a lot like problem number 1 and problem number 2 from this quiz. So I can cancel the 2/3 by dividing by 2/3, but that's the same as multiplying by the reciprocal 3/2. So if I do that on each side, I multiply by 3/2 over here. Remember, here it's going to be, you're going to get 6/6. 3 times 2 and 2 times 3, 6/6 times the variable p or whatever you used, which is just 6/6 is 1. It's going to be 1p. It's just going to be the whole pizza. But then I have to balance the equation, and I have to multiply the right side by the reciprocal 3/2. And so again, to perform that multiplication, one way to do it is to take the integer, multiply by the numerator, the top, the 3, and divide by the denominator. If you get that, we come out with 22.5. In the story, this is money, this is dollars, so I hope that you wouldn't be like, oh, it's going to cost you $22.5. We would say, no, the pizza costs $22.50. Okay. Now, we can do the check step here, which is a good idea to do, and maybe I should have done that before I boxed in the answer, but it does bank on the equation being correct. Me checking 22.5 or $22.50 is going to convince me that it's the correct solution to my equation, but I'd have to be careful to be like, what if my equation was wrong? So yeah, if we do that though, if we do 2/3 times the 22.5, I guess I'll put that in here. Now I'll put 22.50. That's supposed to equal $15. And that would be, I'm going to punch it in on the calculator. It would be 2 times the 22.50. Scoot that over here. 2, the numerator times the integer, 22.5 or 22.50 divided by 3, and we get 15. So that's a good thing. The equation, the check step says 15 equals 15. That's what we're going for. We want a true equation. That is true, that 15 equals 15. So my answer is still that a whole pizza costs $22.50. So again, a large part of that was being able to translate the story into an equation, and then solving the equation is another thing, but it's kind of those pieces. If you can get the equation, that's one piece. That's one bite of the elephant. All right, let's move on to number 8. Number 8 says Kevin has two baskets, each basket containing an apple and a $5 gift card. Brian has 3 baskets, each basket containing 7 apples and a $10 gift card. If the total cost of Kevin and Brian's baskets is $54.26, what is the cost of each apple? One thing I could probably do better is to say we're doing Kevin and Brian's baskets together. You could ask me that on the test, I would tell you. So it's not like, oh, Kevin's basket costs $54.26, and Brian's basket, oh, no, I go, this is together. So for Kevin, if you remember, for me, the baskets are parentheses. So Kevin's got 2 baskets. What's in Kevin's baskets? Each basket contains an apple, so maybe that's A, and a $5 gift card, so maybe that's just 5. And then we're going to add to that Brian's basket. Brian's actually got 3 baskets, so 3 sets of parentheses. What's in Brian's basket? 7 apples and a $10 gift card. And so all of that together is worth $54.26. So again, getting the equation, that's just one part of it. Now to solve the equation, that's the next part. That's the next piece of the puzzle. That's the next bite of the elephant. So this is where we can simplify on the left side. So I'll just see if I can squeeze this in here. We can do a lot of simplifying on the left. So we can distribute the 2 times a is 2a, 2 times 5 is 10. We can distribute that's a positive 3, so I don't have to worry about like, oh, chop slash. I go, no, it's a positive 3. So 3 times 7a, that's going to be 21 apples. 3 times the $10 gift card, that's going to be $30. And that's going to equal $54.26. I can keep going because on the left side here, we've got the 2 apples and the 21 apples. That's going to make 23 apples. We got the $10 and the $30. That's going to make $40. So if we dump out their baskets, we could say, hey, Brian and Kevin, together you're getting 23 apples and $40 in gift cards. And that total is going to be $54.26. So if you can get it down to this point, in my opinion, from here it's very simple. Because now it's a 2-step equation. I just have to subtract the 40 and divide by the 23. So let's see here. What color am I using? We'll go in red. So that'd be 23. The 23 apples are going to cost you, that'll be $14.26. And then let's divide those 23 apples into 23 equal groups because each group will be 1 apple. And so what's 14.26 divided by 23? I got it written down, but let's check on the calculator here. 14.26 divided by 23. That gives us 62 cents. That matches my cheat sheet. So each apple, that's what we're supposed to figure out. Each apple is worth 62 cents. All right, I guess I can write it out like that. Each apple is worth 62 cents. So again, I'll do the check step here. Should have done that before I box in my answers. But let's see here. So that's going to be, this one I might write out or at least a little bit here. So going into the other one. So our check step here. So Kevin's getting 2 baskets. Each basket has an apple, which is worth 62 cents for our apple there, plus the $5 gift card. Plus Brian's got 3 baskets. Each basket has 7 apples. So 7 apples times 62 cents per apple. And we're adding $10 in each of those baskets. And we're supposed to get $54.26 when we do that. So I'm going to do a bunch of this work on the calculator here. So let's see if we do, let's scoot this up a little bit. So if I do 0.62 and I add the 5, this basket is worth $5.62, but I'm going to double that. We're multiplying that by 2. So that's $11.24 for Kevin. Kevin's got $11.24 worth of merchandise or whatever, products. And then in Brian's basket, again, I'll use the calculator here. A single basket, he's got 7 apples times 62 cents per apple. To that, we're adding the $10 gift card. So each of Brian's baskets is worth $14.34, but he's getting 3 of those. So if we triple that, multiply by 3, Brian's baskets altogether are worth $43.02. And so we're hoping that that all equals $54.26. And I know we got the 26 cents, 24 cents and 2 cents is 26 cents. 11 and 43, yeah, that checks out. That's $54.26 is equal to $54.26. So each apple being 62 cents, unless my equation is wrong, that seems like a good answer. Okay, so a lot happening in that one, writing the equation, doing a lot of simplifying. But yeah, that's what we have there. So last 2 questions we'll do here for this video. Just simply checking our instructions for 9 and 10. Tell if the given value is a solution to the given equation. Show, work, or explain. So that's all we got to do is see, do we get a solution? Solution gives you a true equation. That's the idea. We want to get a true equation here, if you can read that there. So number 9, if I take this x value of -4 and I put it into this equation, and I'm just saying, hey, will all of this equal 735 if I do these operations? So 15 times in the parentheses an x value of -4 And then from that, we're going to subtract 3. And then we're closing the given parentheses, we're raising that to the second power. And is that all equal to 735? So I'll break this down. We'll do order of operations. In the parentheses or the groups, we do have an operation. So the 15 is going to wait its turn, and the exponent is going to wait its turn. And is that equal to 735? But negative 4 minus 3, that's a negative 7. Next, we're going to do the exponent. So negative 7 to the second power, that's a positive 49. And now I'm down to my last operation, and I'm hoping to go, ooh, is that equal to 735? Well, let's grab the calculator here. Is 15 times 49, what do we get? I know 5, that's going to end in a 5. Hey, it works out, 735. So our equation says 735 equals 735. Which is a true equation. So is this a solution? Yes. And I might, if this was notes or something, I would write, yes, x equals negative 4 is a solution, but I'll just put yes here. We got a true equation. It is a solution. So number 10 is the same idea. We just have a different variable value. We have a different equation. So if we plug this one in here, see if this comes out to be true. 24 over 3 minus the y value of negative 5, and is that equal to negative 12? So again, order of operations, parentheses or groups. We have the fraction, remember, creates groups. So we do have this group on the bottom, 3 minus negative 5. Before I divide, I want to perform that subtraction. So you could chop that if you want to. 3 minus negative 5, that's the same as 3 plus positive 5, but that's 24 over 8. I don't think that equals negative 12. 24 over 8, that's a positive 3. 3 is not equal to negative 12. So that's a false equation. So is it a solution? No, it is not. It doesn't make the equation true. So that's all we're doing. Remember, 9 and 10, you don't have to solve. You don't have to cancel things. You just have to check and say, if I use this value, do I get a true equation? If you get a true equation, then yes, it's a solution. If you don't get a true equation, then no, it's not a solution. So that's it. So hope that video helped you, and we'll see you in the next one. Thank you, everybody.